Hello, this is Stephen Whitfield with Drilling Contractor. Joining me right now is Raju Gandikota, Chief of Innovations at MindMesh. Mr. Gandikota spoke with us for a feature story that is running in our March-April edition of Drilling Contractor about technologies that are aimed at mitigating downhole dysfunctions. Raju, thank you so much for joining us.
Good afternoon, Stephen. Good to meet you, and thanks for having me in the session.
So one of the things that we spoke about for this story is MindMesh's Remo engineering software platform. So my first question is just, can you explain to our viewers how this platform works?
Sure. Remo is research in mechanics. So it's an engineering platform developed to meet the needs for the changing well engineering and drilling environment. So the basis or the heart of the Remo well engineering platform is a time-based simulation or modeling framework that uses time as a basis to predict models in near real time. So we use time-based models along with time-based data coming in from electronic data recorders as a basis to predict potential harmful drilling dysfunctions, both as a planning tool, as a real-time aid, as well as a post-job analytics tool. So it is bridged to meet the needs for the entire value chain for drilling and completions with this Remo platform.
So one of the things that we also discussed is the predictive capabilities of this Remo platform. And you had actually spoken about this at an IADC Drilling Engineers Committee Tech Forum on performance limiters back in September. So can we talk a little bit about those predictive capabilities? How does the Remo platform help predict dysfunctions?
Excellent. So most of engineering, to give you a perspective how we actually work with real time, you need to understand how typical engineering models are working today. Most of the engineering models are built to work in office environments so that they become more of a planning aid or post-job analysis aid. Our standard workflow does allow us to do both the standard well engineering practice as well as post-job analysis. But what we've done, we've taken this fast-running time-based model and incorporated the ability to read in EDR data, essentially surface well engineering data. By taking real-time information through BitSML or even proprietary data communication capabilities, we were able to take in 1 second or even sub 1 second data from BitSML information and bring it into the Remo platform. By taking just the surface data and using the BHA information or bottom hole assembly information, we now are able to predict in real time drilling dysfunctions. And what we're talking about drilling dysfunction is not just your standard torque and drag and hydraulics that most engineering analysis packages use. We are really talking about downhole drilling dysfunctions that actually are performance limiters. Namely, you're talking about stick slip, bit bounce, axial and lateral vibrations, as well as forward and backward whirl. This predictive model is able to actually to visualize drilling dysfunction in near real time. And that's how you come up with a predictive performance limiter.
You'd also mentioned some of the limitations that standard BHA modeling software has in modeling realistic downhole behavior and how that might be sort of an inhibitor in really examining performance limiters downhole. Could you explain how the Remo platform addresses some of those limitations?
Sure. So again, the engineering community or the drilling community works on standard engineering models that are predominantly either frequency-based or frequency domain analysis, and they use static models to make dynamic decisions. When I say static models, they're using depth-based data or incremental static time-based data so that we're able to predict, let's say, through a frequency mode, the potential for dysfunction. You're not quantitative dysfunction, but they are qualitative dysfunction. So they use critical speed maps as a way to gauge the health of the system. Apart from that, we're also using torque and drag to holistically look at the behavior of the entire drill string, whether you have enough weight at the bit or you have drag issues. But that gives you only part of the picture on what is happening several miles down the earth, near the drill bit and near the bottom hole assembly. By using time-based models and making these time-based models run faster, you have a digital wired pipe that you're able to predict the health of the system before or even as the critical dysfunction events happen. If you're able to visualize these dysfunctions, you can make corrective action, not just the software making corrective actions, but an informed engineer and informed direction drillers can make timely decisions and improve harmful dysfunctions, which are performance limiters.
Well, Raju, thank you so much for taking the time to speak with us both for this video and for the feature story. We really appreciate it.
Thank you, Stephen, for this opportunity. Look forward to collaborate with the industry.
And thank you for visiting Drilling Contractor. Please make sure to check out our feature on technologies aiming to mitigate downhole dysfunctions in the March-April edition.